Hey guys, today's we're going to talk about lines of best fit. So a line of best fit, that's something that you'll hear quite a bit when you're younger, but when you get more into math, you're going to hear regression line. So a regression, not just line, but any type of function, is a type of function that models the data in a scatter plot. So the way that we are going to find an equation of a line of best fit by hand, you're going to be given data. So the first thing you need to do is plot it, and then you are going to, I use a ruler, try to position so that line passes through at least 2 points and kind of gets a general idea of what that guy looks like. And then those 2 points that I passed through, I use those to find the equation of a line, just like I did before. So with this particular guy, we have some data. Our data is going to be from McDonald's about the fat in a sandwich and then the calories. So I went ahead and graphed out, poorly, but graphed out, there's my fat, there's my calories, of all that data. So the next thing I did was I took a ruler and I drew a line through my data. And I had it passing through the points 9, 260 and 3, 560. So those are the 2 points I'm going to use to find the equation of my line. So we know there's a few things we need to do first. We know that we need to find our slope. So we're going to find our slope by taking our y values and subtracting them. So 560 minus 260 over, and then my y value, or my x values, and subtracting them. 31 minus 9. All right, so we'll take 560 minus 260 and get 300. And we'll take 21 minus 9 and get, 31 minus 9 and get 22. Now, you don't know this yet, but here in a few minutes, we're going to be comparing this answer to something that we get with a computer. And so I would like to have this as a decimal because that's how our computer is going to give it to us, and I'd like to be able to compare. So I'm going to go ahead and take 300 and divide it by 22 in my calculator, and I'll end up with about 13.6 for that slope. Now later we're going to have an equation of a line in slope-intercept form, so I would like to go ahead and write this in slope-intercept form. I'm going to use the point 9, 260 to plug in. So we know we have y equals mx plus b. We know our m is going to be 13.6. And then from our point, x is 9 is x, so I can plug 9 in for x. 260 is y, so I'll plug 260 in for y. And now I'm all solved. So we'll take 13.6 times 9. $122.4. And then we'll take 260 minus 122.4. And we end up with 137.6 for b. So by hand, we end up with the equation of a line 13.6 x plus 137.6. Oh, you cannot see that. Oh my goodness, I'm so sorry. So we solved, we ended up with y equals 13.6x plus 137.6. Cool. All right, so now we're going to find a line of best fit with a graphing utility, so Desmos or your graphing calculator or something like that. So once again, a regression, it takes a group of random variables and tries to find a mathematical relationship between them. Most of the time it's linear, a lot of times it's something else. It could be exponential, logarithmic, things like that. Cool. So there's something called interpolating. So interpolating is looking for predictions of values that fall within the given range. So we had everything from 9 grams of fat to 31 grams of fat, right? Anywhere in between there is going to be interpolating. I have calories for everything from 260 to 560, right? So any calorie value between 260 and 560 is going to be interpolating. Extrapolating is predicting values that are outside of your range. So if you wanted to test for maybe 2 grams of fat, right? That's not within our range. Or maybe you wanted to test for 35 grams of fat. That's not within our range. That would be extrapolating. Same thing with the idea for the calories. If we were talking about something that was 100 calories, that would be extrapolating. If we were talking about something that was 700 calories, that would be extrapolating. Cool. So there's a link to how to find a line of best fit on your graphing calculator. And then I'm going to show you how to do it on Desmos right now. So the first thing that we want to do is put in our data. The way we're going to do that is we're first going to click on that plus sign and then click table. And then we're going to start putting in those values. So 9, oopsies, let's go over here, 9, 260. And then we have 13, 320, so on and so forth. So I've gone ahead and put in all of my data before this. Come on, move my face. So there's all my data. Now what we want to do is we want to actually make an equation out of it. So notice my y's are called y1, my x's is called x1. So when I'm going through and trying to write out my, type this out, I need to use y1 and x1. So I know I want y equals mx plus b, right? That's what I'm going for, equation of a line. So instead of y, I'm going to have y1. Now just typing the number 1 will put it down as a subscript. You don't need to do anything silly. Now instead of an equal sign, we're going to use a tilde. And then I want mx plus b, right? So I'm going to have m x1, remember it does the 1 on its own, and then plus b. Now it gives us a few pieces of gives us a few pieces of information here, right? It tells us that m should be 13.9, and it tells us that b should be 138.3. So let's go back and look at this. Okay, so we want to write the line of the equation of the line of best fit, right? So we found out what m is supposed to be. Sorry. We found out from Desmos that m is supposed to be 13.9. And we found out that b is supposed to be 138.3. So if we write this as an equation of a line, we're going to have y equals 13.9x. Sorry, this keeps messing up. 13.9x plus 138.3. So now remember, grams of fat, grams of fat was my x's. Calories was my y. So if I want to interpolate the calories of a sandwich that has 22 grams of fat, well, if it has 22 grams of fat, we'll plug in 22. Let's pop that into our calculator. 1 point times 22 plus 138.3. A sandwich with 22 calories, we can expect it has 444.1 calories. Now we can also go backwards from that. So on this one, they're going to tell me that I want to interpolate the grams of fat for a sandwich that's 350 calories. So in this case, now I'm going to have 350 equals 13.9 x plus 138.3. Okay, so we'll take 350 minus 138.3 and then divide that answer by 13.9. And we end up with 15.2. So it will have 15.2 grams of fat to our best prediction. Now we're going to extrapolate. So we're going to say if we have 40 grams of fat, which sounds insane, but let's say if we have 40 grams of fat, how many calories will that have? So I'm not sure about the number of calories, but I know I'm going to have to take 13.9 times 40 plus 138.3. So let's pop that into our calculator. 13.9 times 40 plus 138.3. Good deal. So that sandwich will have 694.3 calories. Good deal. All right, so the last thing that I wanted to mention was I wanted to compare our two different values that our two different equations that we had. So we had the one from the calculator or from the computer that was 13.9x plus 138.3. Let's go back and look at ours from earlier. It went away. Okay, so on that line we ended up with y equals 13.6x plus 137.6. So if we compare that to what we had from our calculator, we had y equals 13.9x plus 138.3. We were pretty gosh darn close, right? So the one that we did by hand is not too far away from our computer generated one. All right, see you guys later.